Hey, good evening, everyone. Uh, hey, good evening, everyone. Thank you, everyone who was here for the first part of this stream, for joining back in, and for anyone who is here for the coding for price action series for the first time. The In the first episode, we talked about the reasons why we would want to code for price action and some of the benefits and costs of using different platforms and different languages. And this time, we're going to jump right into the example code, which you can see in uh, the event notes details below. It's publicly available. I published it on TradingView, so you can all just open it up and follow along. I am going to share my screen, but you can certainly. There we are. You all can follow along on your own platforms, or if you don't have TradingView, you can follow along in the code, which you can just copy and paste into a notepad. All right. Let's see. Can you all see? Let me just double check. I want to make sure we're here. I don't want to be on top of this. Let's just see here. There is no good option. Let's see. We'll go there. All right. Perfect. All right. Now let's dig in. So for this example piece of code, the reason I put it together this way is because basically it's going to give you many of the best practices that you want to keep in mind for organizing code, for thinking through its function, the things that you want it to be able to do, and then the different components that you'll need to define in order to achieve that goal. So this is a very small indicator. Nothing fancy, but there are some things that we're going to talk about at the end that you all could do to expand this and practice some of the standard kind of PineScript and coding conventions that would be transferable to any other indicator you would build. So let's just go back here. Let's remember the goal of this indicator was to help us better understand behavior around the EMA. So we'll review the features here first, and then after that, we will talk about features of the indicator. We'll go into the code. So first, we define the EMA length, EMA color. We can make it blue for now. Just now, for the band source, I added these three input sources. You can add whatever you want if you want to study something different. But for now, you'll have the full and body range, average body range, and then standard deviation. So for the, it's currently set to full body range. And then the band's look back period is currently set to the same as the EMA, but you could set it to anything you want. And there, we'll talk about later some different reasons why you might want to do that. But for now, you can see here, this is the one standard, one average bar range based on the full bar range. So we selected one here. That means full average bar range. And now we're plotting those above and below. This is the option to have the bands full or not. And then the fill color, which you can change to whatever we want again, and the opacity of the transparency of that fill. So this configures a preliminary study. So again, we can change this to 2 and 3 times the average bar range. And there are a few things that you can pretty quickly tell, except for the gap up. All of the price action for the today was contained within 3 average bar ranges of with the 20 period look back. So quick observations: how much of it is contained within 2? Most of it, and 1 is here, and there's some things that you can observe from that as well. So initially, you can make your preliminary observations about behavior at the EMA. But then you have the bands, which can tell you uh, basically, behavior within more and less volatile environments, um, the degree to which movement across the EMA is subject to the, what Ali calls the electric field around the EMA. That the EMA is not a static point, obviously, but unlike breakouts from bad buy and sell signal bars like this that will often get tested here, this is an exact entry opportunity. The EMA is not exact. So what you want is to better understand and study the behavior and characteristics that you see especially when you have signals, but in general, market behavior around the EMA and in a variety of different conditions. So we can go back and look here. Another gap up. We can quickly throw on the bands to 2 standard deviations. Or sorry, 3 average bar range and 2 average bar range. Change it to body range. So in any case, these are the input parameters that I wrote to configure this for all of your subsequent EMA studies. And this is a baseline. It should be expanded. So let's take a look now at the code and how it's written, how it's organized, and then how you all might modify it moving forward to better suit the kind of studies that you want to do. Are there any questions before we get into the code and how you can use it to both learn how to code and to build something new? All right, cool. So first things first, with PineScript, you need to declare your version number. So this is version 6. Different versions will have different syntax and options for using different functionality. So 6 is the most recent version, so we're using 6. Usually want to state what the indicator does. I don't have extensive comments here because the section titles are pretty straightforward. If there were more complicated functionality, then I would have more comments here that explain each of the modules in greater depth. But this, at least for now, because this is version 1, there's no versioning. But as versions expand, it's a good practice to add, you would add, say, version, oh, sorry, keyboard is off to the side now. Version 2, and then your notes basically here. So good convention. And that way, what you change as you go through it so that you don't have to constantly look back at your version history here. Okay. So as I'm sure you noticed when we were looking at the settings had different titles. So the first one was the EMA config. This is your look back and your color for the EMA itself. And in Pine, the convention is to declare these as inputs. Inputs are what the person interacting with the code defines that can configure it without having to actually go into the code and change anything in the actual Pine. They're user-defined inputs. All of these are the defaults that you see. So default of 20, default of blue, band selector, defaults to full range. And then we see here, this is the bands config. And you create a variable group that allows you to assign different inputs to that group. So when you look at it in your settings, everything is inside of this group. And then you see the tooltips here. You can go back real quick and take a look at that. Anytime you include a tooltip, it will pop up here. So it tells you a bit about what the setting, the inputs are, and how you can use that. So obviously it's set to not fill now. So if I turn it on, no fill. But 1 is fill, so now we have it filled. All right, let's return. These are pretty self-explanatory. And the nice thing about Pine is if you go in, if you do anything, if you want to change anything, you can just hover over the text and control click, and it'll give you all the information you need to know about that. Well, any of the library functions. Anything that you write will not have obviously a pop up and reference in the manual, but there's a lot that you can do just from clicking on the TAEMA and understanding the different ways that you can configure it. Um, it's also interesting, just kind of as an aside, to type in TA and just look at all of the different functions inside of that library. Tons and tons of things that you can do, just stock from the library. And going through this can often give you ideas about how to structure some of your code to achieve specific goals. So here I titled the EMA study EMA and assigned the EMA library to the close, the look back of this. So anytime we change, this is how in any indicator, if you change your input variable, it will change the look back period because it's the EMA function that calls this library is referencing this input. So then here we have the different sources that you saw defined as well. So we have the bar range, which is high minus low, body range, which is the absolute value of the open minus the close, and then the standard deviation of the EMA, which is taking for its inputs. You can see here, if we click on it, the source. So that's the EMA, and you see here that's study EMA, and then a look back length. So that's the band's look back. And then here we defined the band's sources. So source one, if you recall here, was the full range. So band selector, this is band selector. So if, and this is an interesting way that PineScript structures its code to be more efficient. These are tuples, and so basically it's a if-then statement. It's a conditional statement configured in this syntax. So basically what this says is band's source is X if something is true. So what it does is it starts checking to see if any of these things are true. So this means if band selector is equal to 1, then use the average of the bar range, which is bar range, and the look back. However, if band select, and then the colon is, but if band selector is equal to 2, then use the body range. If band selector is equal to 3, use the deviation. Otherwise, don't do anything. And you'll see that used a lot in PineScript code, because it's just a much more efficient way of structuring those kinds of conditional statements. Any questions yet? I learned to code by translating Ali's code, actually, and then becoming rather obsessive about it and learning how to code a number of other things. So yeah, just spending time with it. And it's actually much easier to do this now than it was when I learned 2 years ago. So we'll get into that in the third part of this series, but it's getting easier and easier to learn. So question about the EMA, successful Sultan built with an EMA microchannel and then I'm trying to pull back into the EMA. Typically the EMA is better. It's used more for regime filtering than for a specific entry. You can use it as part of, you can always use it as part of one of the three reasons that you use to take a trade. Minimum 2, preferably 3 reasons that you have to take a trade. However, having a system that is built around entries at the EMA is typically not going to be, it's not going to generate a lot of signals, one. And you have to think about the first principle that you're suggesting, right? I know that there are some people who've recently done research on this. It's one of the reasons why I decided to do the example code around the EMA. But it's not going to. It's one. It's not going to give you a ton of signals. Two, it's going to need relatively wide stops because if you're structuring it around the EMA, then unless you have a better signal to calibrate your expectations, you're going to have pretty wide stops because one of the things that you notice when you first look at the EMA, let's go back to the here, is that if you're like, let's say you're buying, let's say you count this as a wedge, right? This is 1, 2, 3. It's not a good wedge. It's more of a triangle than a wedge. But let's say you miscount this and consider this to be a wedge rather than this being the wedge. 1, 2, 3. So if you counted this as a wedge and you bought here at the EMA, it would be pretty unreasonable to have your stop right here, which means that your stop would probably be down here. So it's going to require you, if you're structuring it around the EMA, you're likely going to have to take larger, wider stops and give it more time because around the EMA, you'll often see more, unless it's a complete price structure, right? And you're breaking out and reversing. You're typically going to see more sideways action around the EMA and lower volatility. So not great to structure the entire system around it, but certainly should inform your research and the way that you actually manage positions. Does that answer your question? But you can follow up here. So let's go on to the next part of the code. So here we've defined the inputs to select the bands. Next, we're actually calculating the bands. So here the upper band is the EMA plus the band source. So this is you're taking the band source here, which is defined by the band selector, and then multiplying it by the show bands. So if you are, and remember, the show bands is not showing any as 0. So if you set it to 0, then you're not going to see the upper and lower bands. But if you set it to 1, then it's going to be your either single standard deviation or 1 average bar range. If you set it to 2, it's going to be 2 standard deviations, 2 average bar ranges, etc., up to 3. And you see the same structure here as well. So when you move through those, sorry, we're not down there. That's the color. But it's the same principle here. So show bands, this is just an economical way to get kind of 2 operations into a single input. So bands multiplied by this will give you the width of the bands. And if you wanted to understand what the behavior is of, like, let's say, rather than a full average bar range on either side, if you wanted to consider just an average bar range across, that would be 0.5. So you could add a input selector to be, so it would be input selector wouldn't change. It would be the show bands that would change. So you would be able to add one here and say, so it would be 1, 2, 3, but you could add one here that is, so it'd be like 0, 1, 2, 3, 4, whereas when 1 would be 0.5. So if you had 0.5, then it would be one average bar range across the EMA. So it'd be half of this. Might be worth studying. All right. So then we come down to band coloring. Coloring is one of the very interesting things that PineScript does and has a lot of flexibility within, because for those of you in PTM, you've seen some very creative coding from one of our stalwart students who's done a lot of coding in PineScript. He does some really, really creative PineScript coding with colors. This is very standard, but The structure is transferable. So if you wanted to do something really creative, you can start implementing some of the other color functionality from here. But it's a good practice to define no color. This is fully transparent. So this is nothing. Basically, what this says is the color of the bands. If show bands is equal to 1, this is so if bands are 1 standard deviation, they'll be orange. If it's 2, they'll be green. If it's 3, they'll be red. So again, here we see that's orange, green, and red. And you can set those to be whatever you want. But that's something that we will talk about in a moment. And then the fill color. The fill color I set up as a input here. So bands fill, and then the bands. This is the color, band fill color. We'll talk more about how you can practice with this at the end. And then the plots. So in order to get anything onto the chart, this is all just logic in order to produce an output, and then you actually have to plot the output. So then the plot function will plot the EMA. So here's the study EMA color, and width here. If you just wanted to have a slightly wider EMA, quite easy to do. Thick EMAs. But then here we see the plots for the bull and bear portions of the band. So this is taking the upper band location value. So here's upper band, lower band, and then band color. So right now band color is the same for the bull and bear bands, but if you wanted to, you could ostensibly change those. And then here's the fill. Fill is a library, a function in PineScript that allows you to define 2 values and then fill the area between them with a color. And that's what this is doing. So I have some ideas for ways that you can expand this if you take this and start doing a study around it. But before we get to that, does anyone have questions about the reason for studying the EMA or why you might want to structure our research this way? All right, cool. So before I let you go, as a project, there are a number of things that I left undone here intentionally. So I did not create an input for the colors of the bands, right? These are hard coded here. What you might want to do is take this example, bands color, right? This is the fill color, and create a new input, a new color input, and set that to the bands rather than having it hard coded here. Does that make sense? So you would be able to define the band color for bands 1, 2, and 3 for each of these inputs. And doing that, provide users with an input, well, really yourself with an input for defining each of those colors individually. You could also add inputs. So right now we have bar range, body range, and deviation of the EMA. You could add any variety of inputs. So you could change. Well, actually, obviously, you can change the look back. But think about other band sources that you might want to take. For example, you could do the high-low close HL in PineScript. It's written as the HLC3. So you take this as one of your input sources rather than just using these 3. So you would add a source to this group here. Then you can, so currently, all of the, let me see here, where would it be? we would want to add it here. Okay, so then there is a function in PineScript that allows you to import the output of another indicator. Basically, it allows you to chain indicators together. And I will leave this with you as a mystery assignment. But what you can do is, so for those of you in PTM or in Systems Academy, you have the breakout paint bar code, which uh, is here. So this is the most recent translation that I've done of it. If you were to turn on, let's say, your bull and bear breakout bars. So these are unfiltered, unconfigured. They're just any bar that's a bull breakout or a bear breakout. You could take these. So this is the output of this indicator is something, at least this output is the signal value. So it's showing you here the value of signal, the signal variable. That's -1. This is 0. That's 1, 1. So as you can see, this would be this value. So if you take that value as the output and take it as the input of your EMA, then you could basically flag any bar within the bands. So if you could create conditional blocks that say, if signal is equal to, and actually we can write this out real quick. Let's do this before the coloring. Sorry. So So now it would be, because the value is signal, so it would be signal equals 1, then, and close is, actually, we may want to take this as a separate, well, for now we'll write it this way, but if signal is equal to 1 and close is well, we'll just say upper band, close is less than the upper band, and close is greater than the lower. Do we say 1? So this is the one way of, sorry. Oh, because I haven't imported it, it's going to give me, so this is going to give me an error because I don't have a signal variable in this code. But actually, let's just write that out real quick, just so it doesn't give us that error and we can compile the script. Okay, so we don't have a signal variable. Well, we aren't taking an input signal. We don't have a signal chain that is processing the variable called signal, but it wasn't going to let us compile the script until there was something that this was referring to. So what you could do, though, is take the input from another indicator and then use these different ranges. So you could change your filtered your source for the bands and say, so it's 1 or 2 standard deviations, it's the body close, it's the body range or the full range, and then look at any bar that is a signal bar and which is closing within that range. So within, greater than the EMA. So basically you could look within only the upper band within both of the bands together. So you could configure a number of different studies. And the interesting thing is that you can then just go and export your chart data and take the CSV and just start researching, start organizing your study. So it would be part of the data that you could capture when you do a preliminary signal study, for system development or just general price action research. So for the system developer or the astute price action researcher. Let me see. Kasra, let's see. How do you use the EMA for trend or trading range regimes? So for the this doesn't have angle calculations in it, but one of the best ways to think about, a regime is not necessarily trend or trading range, right? The regime is bull or bear. Whether the market cycle is in a trend or a trading range is a different consideration, right? Because you could have a bull regime above the EMA that's in a trading range, as it is here. And the best way to filter for the actual market cycle or the strength of the market cycle is EMA. So there are other better ways, but the as a proxy for market cycle, the angle of the EMA is a pretty good one. And we talk about that a lot in Systems Academy. You're with Ali this year, so you'll have plenty of those conversations. And we have the code that we've written for studying the angle of it, and capturing that as part of your system study will be valuable. The paint bar, there are students who have completed it for NT8. Ali did not do that translation, just as I did the translation for PineScript. But I don't know that they're available outside of the NT8 version is available outside of Systems Academy. Are you with Ali in Systems Academy this year? Gasper, you're welcome. Glad that you jumped in here. So before we break, let me just add. I want to do a quick write up of the things that you should consider. Where is the? All right, we're going to go with the screen. Sorry about the many windows there, but all right, here we go. So items for further study. So you can add color inputs for band colors. Add additional band sources. You could add a fourth option to show all band levels. And under this, if you get really creative, you can option to configure fill by band range So this would be, let's just say you have EMA here, and then so the idea is that you could uh, color only or fill only within the outer bands and then have the inner bands. So this, if this is your EMA and these are your upper and lower bands of the first deviation or first average bar range, then two times or two standard deviations, you could have, you could add the option to fill only specific ranges between those thresholds. That would be a fun project. And then 4, add input of AMA breakout paint bar or other indicator to start signal study. All right. I think that should keep everyone pretty busy. Um, please let me know if you leave questions in the comments. I'll try to get to those, whether it's wonderful successes or struggles with adding any of the functionality, or if you just start using it to begin collecting data and conducting research. I'd love to hear about it. Any questions before we wrap up? Oh, way. Nice to see you. Let me see. Yeah, there is the Christina. There is the first version. That might be the one that I have. When I was doing market replay with the paint bar, I did. I mean, this was almost 2 years ago, but that was the one that I was probably the one that I used. I don't know that it's been updated much since then, but I can check. I'll find out. All right. Well, thank you all for tuning in this evening. Well, in the third section of this series, I'm going to talk about how to use different AI tools to not do your coding for you, but to help troubleshoot issues that you run into, and then also to teach you better coding conventions. One of the things that I learned, by by fire was a lot of the just standard coding best practices that I simply didn't know existed. And then since then, and working in Python and IDE environments, the whole slew of other things which that have come along since then. So you can use them as basically teaching tools alongside your coding to help you troubleshoot logical inconsistencies, syntax, and it can reference libraries and help you resolve errors that are sometimes difficult to diagnose. But I think that it's still disproportionately more valuable to try to do the coding yourself. And we can talk about why. So to be continued. We'll see you all next time. And for those of you thinking about Systems Academy and how you would bring a tool like this into your research, this is something that we will be talking about. I mean, having written this now, there are folks in here from Systems Academy, so I'm sure they will probably use this for a bit of their EMA research, or at least when they collect some EMA data. So it's definitely something that you could use in a variety of system research and design contexts. So, look forward to hearing how you all use this. You can also leave comments in TradingView. I'll read those as well. All right. Have a good night, everyone.